In this lecture, we want to explore how capturing by reference works under the hood. And again, the compiler is going to be generating a functor behind the scenes. Let's look at a simple example to really drive this home. Here we have a lambda function, which is going to be capturing A and B by reference. And we will be doing stuff with the data we capture in the lambda function. You can see here we are trying to modify. So modifying from a lambda function that is capturing by reference is allowed because what you have is the reference to the data that exists at the outside of the lambda function. So modifications like this are allowed. We can print our data, we can print the data we get in the parameters, and any change we do from the inside on the captured data is going to be visible from the outside of the lambda function. And any change we do from the outside is going to be visible in the lambda function when we hit the execution of the body of our lambda function here. This is something you should keep in mind. Once we set up a lambda function like this, our compiler is going to generate a functor which is going to set up member variables that are references to the outside data that we have captured. So the data is going to be passed to our functor by reference. You can see that here. And the data is also going to be stored as reference in our member variables. You really should be able to see this. So what this says, if we do any modification from the member function, we will be modifying references to the data we have on the outside. And if we do any modification from the outside, the changes are going to be reflected in our member function here, and everything we do from our lambda function is going to be visible to the outside. This is the idea I want to convey here. It is also possible to capture everything by reference by using the syntax we see right here. And just like capturing by value, the things we generate member variables for are only things that we use in our body of the lambda function. If there is something that is not used, we won't be able to generate a member variable for that, and we won't see that when we hit Visual Studio Code and try to use these things in CPP Insights. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is capturing by reference under the hood. We will grab the code from our template files and use that in our current project. And we will open this up in Visual Studio Code. Let's do that by dragging and dropping here. We will have our main CPP file that we clean up a little bit. We will set up our variables that we want to capture in our lambda function. Again, we have A and B and some var and some other var as we had exactly in the last lecture. And we will set up a lambda function which is going to capture stuff by reference. Here we will first capture A and B by reference by using the syntax we already know. So this is going to capture A and B by reference. And what we have in the lambda function is going to be references to the data we have on the outside. So the A here is going to be a reference to the A on the outside. The B here is going to be a reference to the B we have on the outside here. And everything is going to work really well. Now, because we are capturing by reference, we have the ability to modify the data that we capture because this is really not going to do any disturbance to the data because the data is already available on the outside anyway. So for example, if we go down and say func and pass in 10 and 20 like we did in the last lecture, this is going to call our lambda function, and we will see that by the time we print this little guy, A is going to be already incremented. And if we go on the outside and try to print A itself from the outside, we're going to see that A has already been modified. And the changes we did in our lambda function are going to be reflected from the outside even after the lambda function has finished execution. This is the idea I want to drive home here. So let's pass this through our GCC compiler. The build is good, so we can bring up a terminal window and run our code. We can clear and run Rooster. If we print things out, we're going to see that we have captured A to be 8 and B to be 3. A has already been incremented, but after the lambda function runs, we will see that the A we print from the outside has also already been incremented to 8. So the change we did in our lambda function is reflecting on the outside even after the lambda function has finished the execution. And this is working like this because the lambda function is powered by a functor that is setting up member variables that are references to the data we have on the outside. So let's try and grab the code here and put that in CPP Insights to see what the compiler is going to generate for us. This is a really good tool to explore these things. We're going to pass this through the tool and we're going to wait for a response here. And if we look here, we're going to see our functor, which is generated. We have our function called operator. It is cost. And it is going to allow us to modify the reference member variables because they really aren't things that belong to this class here. These are really like pointers to something that is on the outside. We won't be modifying these references to make them point to another location, for example. We will just be changing the data that these references are referencing. So this is allowed to do because if we do something like this, we aren't modifying the data that is really in this class. We are modifying the data that lives somewhere else. Hopefully this is making some sense. So this is our functor, and it is going to model our member variables as references to the data that we have captured in our lambda function here by reference. This is what I want you to understand. Again, we also have the ability to capture everything by reference, so we can change our lambda function to be something like this in CPP Insights. And if we do this, we want to generate member variables for everything. We will only generate member variables for things that we use in the body of our lambda function here. So we are using A and B, and we're not using some var and some other var. So we will only generate member variables only for A and B, even if we are capturing everything in our capture list here. Let's pass this through our tool. We're going to wait for the response and see what is generated on the right here. So the data is ready. We have our functor, which is generated, and you see that we have only generated the member variables for A and B because these are the only things we use in our lambda function here. If we went in and, for example, printed out some var, we can go down and say stdc out. And let's make sure this is the same name we have here. We're going to see that now we're going to generate a member variable for some var, and we're going to change the number of member variables here to 3 and add this little guy. Let's pass this through our tool and wait for the response. The data is ready, and if we scroll down, we're going to see that now we have 3 member variables, and this one is used in the body of our lambda function. That's why we need another member variable for it to make it possible to capture it and use it in the body of our function called operator. Hopefully this is making some sense. This is really all I had to share in this lecture to show you the mechanism to capture by reference and how it works behind the scenes. The compiler is really going to do what we know it is going to do for lambda functions. It is going to set up a functor, and it is going to use reference member variables to model the things that we capture by references here. And any change we do on our captured data in our lambda function is going to be reflected on the outside, because what we really have in our lambda function are going to be references to the outside data. We are going to stop here in this lecture. In the next one, we are going to explore the idea of mixed capturing, where we capture by reference and by value at the same time. And we're going to see how the compiler models that in a functor that is generated to support that lambda function. Go ahead and finish up here and meet me there.